Good morning, everyone.
Good morning.
Morning.
We're going to talk about a subject which is usually doom and gloom, but we're going to be quite excited and positive about it. And I'm going to do a very short framing of this, and then I'm going to turn it over to Larry Smarr, because he and I talked about this on that road trip in that little silver car. We attacked the question of climate change or global warming in the CTO design challenge, I think 5 or 6 years ago. And they did a brilliant job. And we captured everything on film. We had a judge who was world famous who had said it couldn't be done in the opening night speech, and he had decided they had done it. And we took all the material, we took the PowerPoints, cover letter, and so on. We put it all into a FedEx box, and we sent out 535 of these to everybody in Congress in the United States. And then we waited. We didn't get a single phone call or email.
Right.
We sent them the solution, and we didn't even get a call back. So at that point, I thought, let's try something else. Perhaps the private sector is a better way to go. And we've been working on this problem now, I think, for probably 5 years, maybe a little longer. And we think that we have actually solved it. There is actually a solution. After all the stuff you've heard in the world about how we're all doomed, I think there's actually a really clever solution which we're going to describe to you today. And there's no better person to begin this conversation, I think, than Larry. So Larry, take it away.
Thanks. Well, about that time, about 6 years ago, I was, bring up the PowerPoint, I was giving a number of talks on global climate change and in particular what causes it, which is the global energy system. And just to put it in context, here's the last 800,000 years of the carbon dioxide concentration in parts per million on Earth. You'll see back then, 2008, was moving up to 400, and now it has crossed 400 essentially permanently. And so we're into a regime which we haven't seen over the last 800,000 years, and if you actually look back, it's actually millions of years since the Earth has had that much CO2 in the atmosphere. Now, we're trying, if we don't do anything, we're going up to the top, and this is, by the way, that vertical line is to scale time-wise, and so there's two examples I'm going to show you. The so-called IEA Blue, the International Energy Agency, that's the OECD group that tracks the global energy system. And then Shell, which is very famous for scenarios, their blue scenarios. So these are the two, if you want to look them up. Now these are back, I'm just showing you from 2010. These have been, of course, updated and so forth, so you could update these numbers. But the general idea is going to be the same. So we just crossed 400. So if you can actually change the world to level it off at 450, that would be a minor miracle, actually a major miracle. 550 is a little more conservative, but still a Herculean effort. So in terms of the graphene, here's what you have to do. You have to first of all realize that by 2050, the global energy demand will have doubled. And then if you look at all of the so-called wedges, the sources of energy that are used by the global energy system, oil, gas, coal, nuclear, hydro, solar, wind, and so forth, that big black part is coal. And below it, the green part is natural gas, and the red part is oil. So those are all directly adding CO2 to the atmosphere. Now, what the Shell scenario says is that we have to, you can see how the pink, which is wind, enormously increases from where we are now, and so does the, right below it, the solar. So assuming we go at a fantastic rate of adding solar and wind, renewables basically. In addition, the fixed points of all of the CO2 emitting coal and natural gas sites have to be, that carbon has to be captured at the smokestack basically and done something with. And of course, at these days, it was saying, well, we're just going to drill it down and put it in the ground. That's sequestration. Instead, what we're going to hear is a much more exciting idea that we're going to be able to turn that into materials like graphene and other things. Now to do that, to just capture and do something with it is going to require us building a infrastructure twice the scale of the natural gas infrastructure, which is all the pipelines, all the tankers, all the storage facilities worldwide. Now that's to just hold it at 550. So it's 90% of the, of the OECD and 50%, say, of China and so forth. But actually, you need 100% of it, as you can see. That black part, you notice there's no black at 2050 in the blue. That's at 450. So that would mean you'd have to essentially capture all of China and India and Europe and the US. And so you have this massive, massive, massive amount of CO2. And if you don't do that, then you're going to move to a planet that actually, in the entire evolution of the Homo genus, we've never seen a planet like that. And that goes back to the monkeys, I mean, up in the trees. And so we have got to do it. And the problem has been, what are the innovations that can add this? We're going to have to do everything we possibly can. But this graphene thing is a completely out of left field. It's once again an example of what Mark and FiRe have been able to do is to say, how are we going to think our way? How are we going to innovate our way out of this? So that's the setup. We have a gigantic market opportunity with all this CO2 that we're going to have to capture anyway as part of what we're going to have to do as a planet to react to this. But you could either put it underground where it's useless, or you could actually turn it into something that would be incredibly useful, and that's what we're going to talk about.
Right. So I'll do a little more framing here. So those, let's see, how many people, if you just raise your hand, if you have heard of the SNS Carbon Trifecta proposal? Pretty good number, okay, about half, I guess. So for those of you who have not, we'll do a quick framing of what that's about. And I'll add from that earlier CTO challenge that one of the most important things that these brilliant guys discovered during their 3 days of talk was that there was not a single answer. So everyone's working on what's the answer? And they said, well, wait a minute, there isn't the answer. It turns out it has to be a multi-phased response. And that's because there's a period of about 20 or 30 years starting now, which is extremely important because everything we do, every hour we save, every CO2 molecule that we don't put out right now is amplified by many, many times later on in the cycle. And it stays in the atmosphere and causes more time damage than now. So they said, because of all this, we have to have a transitional plan for right now to the next 20 to 30 years, and then we have to have a final solution, which we have 20 or 30 years to put into place. It seems to me that almost no one is thinking like that. Everyone's talking about the final solution. But we know that China's building a coal plant a week. So clearly, we need to make friends of our not friends, and we need to do this, find something which makes us all colleagues in arms, and which also solves the problem of the next 20 or 30 years, which nobody seems to be paying attention to. Because the ideal answer is going to be, our way of creating the solution, I hate to say saving the planet, but maybe, is to say, look, you guys keep doing what you're doing, but we need someone who can turn on a year from now on Monday morning at 9 o'clock. And if we figure out what that is and really get that going, then it'll all work. So here's what happened. This is a little bit hard to get your mind around, so I'm going to be careful and say it clearly. The reason this hasn't come up, I think, until we came up with it, is that it's got about 5 moving parts to it. So the first question Larry quite clearly described. There's too much CO2. That's obvious. Unfortunately, we have politics, as you may have noticed. So currently, all the entrenched powers are fighting any mention even of the words, which I resist every day. So global warming, global warming, global warming. But even if you're allowed to say the words, you still have enemies. We can't have any enemies in this conversation. So we want to make business partners out of everybody. So we need to recruit the interest and money and support of those people who are used to opposing any change. And to do that, they've got to make some money. So that's one of the equations. How do you do that? The next is the chemical equation, which we're going to have John talk about in a minute, which is how do you literally take CO2 into something instead of stuffing it in the ground. It's got to be something of value. It took me a little while to figure it out, but I finally discovered graphene for us, and it was like, that looked pretty good. That it does everything. You make everything in this room could be made out of graphene. So that has the chemical capacity to solve this problem. So that's another equation. Then the question is, if you found that thing, you need to figure out how to make it, and that's where John's going to come in a minute. And then once you've figured out how to make it, you've got a much bigger problem, which is there's no market right now. It's a brand new discovery. How do we get this? And as Larry's mentioned, we've got to do about 6 or 7 gigatons a year. And I think John will talk a little bit about that too. So this is a gigantic amount of stuff. And how will we create a market? And then suddenly there's a kind of a simultaneous equation that goes with that, which is 3D printing. Obviously, whatever you do, you're going to have to manufacture stuff, right? Well, how are you going to manufacture stuff with graphene in it? Well, there's another problem to be solved, which is a dependent problem. That is, 3D printing is wonderful, but it's dependent upon the number of jets in a 3D printer. And so we really haven't seen the explosion we thought we would see in 3D printing as a manufacturing process. But if we could find a chemical that was not an inkjet limiting problem, because you can make everything in this room out of it, then 3D printing with inkjets becomes pretty useful. So as you'll hear from Ray and Soroush, I think this is actually being done already, and it's a really interesting thing, and suddenly the doors are open. We could actually additive manufacture everything in this room with graphene, or a graphene product. So that all gets solved. And then, by the way, we ended up solving one more equation that nobody was worried about, which was, over the long term, like 100 years or more, we've been using resource exhaustion as our model for how to run the Earth, and that exhausts our resources. So the idea is you dig up iron until it's too expensive to use anymore, and hopefully you find something else. But someday, we're going to run out of that stuff, and so at some point, before everything becomes too expensive and too rare, and ends up in our garbage pits, we ought to be shifting over to a materials program which is sustainable. I mean, so imagine if we were sitting here 100 years from now and the entire building had been made out of graphene, including the windows, your clothing, this stage, all the electronics, the chips, and in fact, everything. So the windows, imagine it. So we not only solve the problem of lower and lower cost production, but we also solve the problem of you can just shred all your clothing, turn into a Boeing airplane, shred the Boeing airplane, turn it into the tables you're at, shred the tables, turn it into a TV set. That works. That could be done. We could actually end up printing whole cars or whole houses, everything in them, windows and all. So this is all technically feasible. The question is, do we have the will to do it? And one of the things that came up during this CTO challenge was will. And I think there was a term that we coined, a Churchillian moment. We can't sit around here and mess with each other anymore. I think Larry painted a very clear picture for us. The time is now. We know what to do. We've got to do something. So we're hoping that you will help us evangelize this. I'll mention that we have now, thanks to John and some other folks, received the support of 4 national laboratories in the United States. So we're getting it going. But we have a long way to go, and we're going to hope that all of you might want to join up as we form a consortium for this project. John, would you please explain to us how is it possible to take CO2 out of smokestacks and turn it into the most important chemical in the world?
Sure. There's, just to put it all in perspective,
So they pulled John?
I do have to say, the laughs are actually really appropriate, because I worked with several guys who took this on over a period of 6-7 years, sort of deconstructing the emissions problem, much like that fellow who tilted at windmills, right? Yes. Thinking that he could do something that is worth a laugh. At any rate, so how do you reduce carbon dioxide to carbon? Well, why would you do it, first of all? Right? So carbon is a building material. All you have to do is look at all the trees out there. Think of your own skeleton. We are carbon beings, and we're carbon beings for a reason. This planet is made of living carbon buildings, structures, etc. So the thesis that carbon could be useful as a building material is manifest. Can't argue with it. So how do you reduce carbon dioxide to a carbon building material? And what some other scientists and I took on. And we looked at a lot of different ways to do it, but came down to one, which is using magnesium as a catalyst. Now, it's nice to be here in Salt Lake because down the road, about 60 miles, is the largest magnesium production plant in the US, the only remaining one, because every other one has been put out of business by China, underpricing their magnesium. This one survives partly because it's viewed as strategic by the DoD, so they get a lot of preferred business, but it's a very large plant. Now, how do you react or tear apart carbon dioxide? That molecule's very happy being together. So in chemistry, it usually takes a lot of energy to break a molecule, break up a molecule. You have to find a material that is willing to give energy, and that material is magnesium. So when you react magnesium with carbon dioxide, that's an exothermic reaction. That is an energy-producing reaction. The magnesium wants that oxygen so much more than the carbon that it's willing to pay a credit, an energy credit, to obtain it. So it's a very simple reaction. It's well known. You can look on YouTube. You can see people combusting magnesium in dry ice. It's a cute experiment. It's great for the science rooms and teachers and so forth. What people had not looked at was what the resultant material from that reaction was. We did that, and we patented it. It's a form of nanocarbon, graphene. Well, graphene is a nice reduced form of this carbon in a tight structure that has a lot of structural integrity and is a great building block. So that is how you get there. Now, just from an economic point of view, can you scale this? And the answer is yes. Is it economic? The answer is yes. That magnesium from that plant can be recycled. In fact, that's done today because magnesium is used as a catalyst to produce titanium. And there is a titanium plant co-located at US Magnesium on the Salt Lake. So the economics are readily available. The recycling models are readily available. The spreadsheets have been done, and we understand that we can produce at scale carbon graphene from carbon dioxide at a cost just a little bit above carbon black. So way down in the sweet spot of industrial costs.
You know, if there were any coal plants in Utah, it would almost sound as though you were suggesting that we try to do a pilot plant in this state.
Well, there are coal plants.
Oh, there are? Oh, well, that's interesting.
All right.
Well, if there were any people from Utah in the audience, that would be kind of interesting.
Could be.
Anybody from the lieutenant governor's office?
Yeah, like the lieutenant governor's office, or okay. So
Utah's the perfect demo site.
it might be a very good place to start this revolution. Ray Gibbs, would you talk to us about a couple different things? You know what you're going to talk about.
Yeah.
We want to hear about graphene as a material that Ray produces a lot of this stuff at Haydale. So go ahead.
Okay, I want to talk about Huntsman, because Huntsman was formed here. Huntsman, $10 billion turnover business, NASDAQ quoted company, chemical company.
Yeah.
We've worked with them now for about 18 months, and we've added some of our graphenes and some other materials into the high-end epoxy resin known as araldite. And we've increased the thermal heat capacity of araldite by about 400%. In the world today, heat management is massive, absolutely massive. And they are hell-bent on making things happen using their resin and our material. So think about the car, the aluminum and steel that's driven into the car. We have added the resin with our material into a carbon fiber layup. And instead of getting the bubble on the surface that you have to keep on rubbing down to make the surface acceptable to be added to a vehicle, the thermal heat management absolutely creates a surface which is capable of being sprayed on. So over time, why cannot we change the model that says, let's get rid of aluminum, let's get rid of steel, and put carbon fiber with the resin in it? Think of the saving of the energy that you could do with that.
And both those cost huge amounts of energy to make, so that's good.
Yeah.
And the lightweighting is another complete.
Correct.
Yeah.
And then I want to talk about briefly printing, 3D printing, because that can stop trucking of goods and services everywhere. But how can we do that? Well, we've launched yesterday, actually, 3D printing PLA graphene-loaded filaments. PLA, polylactol acid. The source of that is corn, sugar beets, potatoes, so it's earth-friendly. And we've added 0.5% of our graphenes into that material. Because it's managing the thermal heat management, you can speed up the process of 3D printing, which is the biggest constrainer to getting 3D printing in the marketplace today. And we can increase the speed by between 3 and 4 times. The layup is brilliant. The stiffness and strength increases by 50%. And we're getting some really interesting feedback from the customers and potentially people like Big Rep in Germany who actually 3D print the inside of a car for production to BMW. So they pre-production prototype. And they're already talking about making this material, using some materials, and printing straight from a CAD drawing, creating the part.
Cool.
Okay.
Very cool.
So that's really what we're doing, and it's all about opportunity.
We talked to a guy who's a very famous PhD at ASU, who studies several things, including this. And he underlined the fact that at first he wasn't interested in our project. And I said, is there a problem? And he said, well, you don't realize how much stuff we're talking about here.
Mm-hmm.
And I said, well, what do you mean? He said, well, you're talking about gigatons per year. Yeah. And so I said, well, actually, you know, we want to make bricks. We want to replace cement. And we want to make cars. We want to make airplanes. We think we make all this stuff. He said, oh, I'm in. So it is a huge project.
Yeah.
And I think it's worth saying a lot of money to be made.
The interesting point there, Mark, is that one of our other collaboration partners is a company called the Advanced Metallurgy Group, NASDAQ-quoted billion-dollar business. And they mine graphite out of the ground, which is one of the precursors for the graphene that we use. And the CEO is absolutely besotted with CO2. He measures everything in his business by CO2 emissions.
Right.
Everything. And he wants to industrialize what we do.
That's
and he's setting up a plant in Haydale in Germany to do that.
Yeah. I think a lot of things that the Germans are doing are the future. You can't see them. They have a lot of alternative energy. People didn't think they could ramp up that fast.
They need wind turbine blades, like I say, turned off everything else.
Right.
Wind turbine blades have got issues because they crack, because they need graphene in there to thermally manage the exothermic reactions, because this is 200 mil thick. It's massive, these wind turbine blades, and they crack because they can't manage the exothermic reaction on the resin without the material we got.
So obviously the challenge, part of this challenge is to make enough graphene. That's a big deal. And another part of the challenge is to develop the markets quickly enough so that there's a match there. Soroush, what do you think?
Yeah, there is no single answer for this global warming. So one side, as you said, you have to capture the CO2 and use it, and the other side, you have to prevent the emission of the CO2. So to my understanding, you have to go sector by sector to see where CO2 is being mostly emission. My interest is mostly on transportation segment, which is technically 26% of the US global CO2 emission at 2014. So EPA is setting good regulation, but the problem is they're setting it very abrupt. So get to 50 mpg by 2027. It's even worse in the, let's say, heavy-duty trucks. By 2022, it has to be even worse. So there's a lot of requirements for automakers to innovate in this segment. Graphene is one of them. Technically, you either have to reduce the weight of the vehicles, whatever size it is, or you have to improve this electrification process, go through the electric sources, having better batteries. Funny enough, graphene can add value to both stories, can improve the batteries to extend the range of the vehicles by improving the energy capacity of the batteries, and at the same time can replace metals with the plastics and brings performance to them, which reduce up to 40% weight of the vehicle, which in the long run you will see that will translate to quite decent reduction in the carbon emission. I would say I'm not sure about the U.S. government, but in Canada, we see some movement by the government to improve this CO2 emission. We recently won a large project from government of Canada to include graphene into the plastic and bring it to bus, trucks, and electric motor-driven system to reduce their weight and improve this fuel consumption. And technically, it will help a lot when you move toward electrification. Just think about when you move toward the electric vehicles or electric truck, all the weight is not anymore localized on the chassis. You have a lot of batteries spread out all over the car. So you can replace the chassis from an aluminum piece to a plastic piece. You don't need that much strength now. Any pull-through-that fiberglass or carbon fiber can do the job. But adding graphene to that can further extend the performance of those trucks and buses. So you see, by finding sustainable applications for graphene that businesses can make money, at the same time reduce the CO2, I think that's the main potential short-term solution, as well as finding solutions to make graphene through the CO2 in the long run. Together, that may solve big challenge in the global warming.
Right. I saw, you might know about this, Ray. There was a company in UK that's just made a graphene bicycle frame. Did you see that?
Correct, DASI. DASI
Yeah.
brakes, yep.
Yeah. And
Yep.
they showed a picture of this guy holding it with like one finger. And it's a very strong frame. It's stronger than steel. And it weighed, I was doing the math, like he said, the next generation, I think the next generation is going to weigh 1 pound or something like that.
Yeah, he's approached us as well to help him do that.
Yeah.
Yeah, Stuart Abbott is an entrepreneur in that. Each bike, by the way, costs around about $25,000.
Yeah.
So it's,
Right.
it's not a,
Today.
it's not a cheap thing.
Yeah.
But he's got visions on that bike of having the frame work to the mechanics of the person that's pedaling, so that the frame is set for that and increases the efficiency by 15-20% just by making the frame right. And we've got a program with him working to reduce the graphene frame again.
It just struck home to me, this, whether it's a car or a truck or an airplane, but the light weighting isn't going to be 10%. It's going to be a radically larger number, and that will change how we think about material. I mean, this thing weighs a fair amount, but if this were made out of graphene, you could probably lift it with part of one hand.
So it's a new approach, Mark. It's technically before people were all trying to improve the manufacturing process to get things better and cheaper. But now the recent story is improving the material and the building block of those trucks and buses to reduce the weight, not changing the typical manufacturing process.
One thing to add, in Huntsman's terms, working with us, because they want to protect their brand name, Araldite, 2 questions came up. One, what is the sustainability of your product, of the material? Where can you get it? Where can you consistently get it? All the time, sustainability. Secondly, disaster recovery. Make sure that we can, if something goes wrong, you can actually do that because they're desperately keen to make sure that all the gazillions of dollars they put into Araldite brand.
Well, if they had a thing here in Utah, that would probably help solve that problem.
Indeed.
But
Larry.
Mark, I just want to make a very obvious point. This is all about China. If China, we can do all we want in Utah and the US, it won't make any difference to the planet's carbon dioxide balance. All that coal that you saw, that big black thing, almost all of that is in China. So we have got to find a way to engage China to let them see that this is one of those things, not just building solar and wind and so forth, but because China has to go amazingly aggressively. Now, the good thing about China, put aside the intellectual property theft issues, is that when they decide to do something at scale, they are better than anybody in the world at it, particularly in the energy sector. So I think that finding a way to work with China is absolutely critical, and what we've seen between what Obama has done with Chinese leaders recently in this is very hopeful, but I would love to see, they have to take a lead on this, because it's a scale issue. It's where those gigatons are being generated.
I think that not only has it started in terms of diplomacy, but one of the best pieces of news about this is it gives us a way to work with China, which is a happy story.
Correct.
And they are nothing but motivated about this. So the standing committee loses sleep at night, I think, over the issue of pollution. It is the most likely thing to cause a revolution in China.
It is.
And you can't hide it. So the people, they figured it out, you know. And if they came up with this, if they owned this for their own, and the people of China would be very excited. I think they'd feel that their government was responding to and not being deaf to the problem. So I have every reason to believe that this actually would work. And I would expect that what we'd want to do is open source all this stuff at some point. John's got to get paid for this. But basically,
Not
you know,
much.
there's going to be so much money in this project that what you want to do is kind of what an Elon thing would do with, you know, HTT or so. You want to open source this, get everybody involved, let everybody make money, and put the pedal to the
Yeah, well, what we heard yesterday about the Hyperloop is the comment was, look, we're making an entire new industry. Of course, there are going to be multiple companies, there are going to be multiple companies. We are going to build an entire new industry, and that's what has to happen in an insanely short time.
That's right. Well, we've gone over, which I don't let anyone do.
I know you don't.
And if any of you would like more information, or if you'd like to join up with this brand new consortium, we'd love to have you. Send an email to Mark, M-A-R-K, @stratnews.com, and we'll get you signed up. Thank you.
Thank you.